think it's recording. Okay, just give me a minute. I'll record it here. Yeah. Okay. So today what I want to discuss is something, like a little different than what we the kind of system design problems that we get. But I've worked across multiple companies and everyone's doing this, like everyone's building this GPT wrappers on top of it and just saying that, this is a very powerful tool that we are building and this does something like that, right? So what is a Gen AI app? Or it's just a cool term people use. So it's basically a wrapper on top of GPT, right? So I'll show you an example, right? See this API documentation tool, right? So how many of you write Swagger? Like how many backend devs are here?
I am.
Okay. So Himanshu, you write Swagger, right? You
Yeah,
write,
yeah.
right? So how do you write Swagger docs? Do you write it manually or what is the way you do?
Yeah, now I guess it's automated. We just have to add a plugin. And in Spring Boot, talking about.
Exactly. So for Spring Boot, you
Usually
have,
manual, but
yeah,
we
yeah, exactly. So see, for Spring Boot, you have a plugin. For C Sharp, you have a plugin. But the issue with these plugins is, it's very language specific plugins, right? A lot of languages don't have these plugins. Like TypeScript, you don't have a good plugin. You have something like Joey with TypeScript or something. But again, it's a use case that you see, right? Like I was in Slice, right? I was told to create Swagger, and it's like we manually wrote all the Swagger stuff, right? So a lot of people, like you can say about 50-60% devs in the world are still writing Swagger manually. So this is a use case where you can use Gen AI to automate it, to make it better, right? Now the thing is, your company has come to you and they have told you that, okay, this is a Gen AI thing that we are going to build, right? So how do you go about building it, right? Like let's just say we have to build this tool, right? Docurator.ai. I want to go through it, right? Because again, someone has thought of it, someone has built it, right? The idea is to understand how this kind of tools work. So this tool is simple. Okay, you have a they have this UI, they have a dashboard of sorts. Let me just see, where is it, free tools, right? So they have this kind of dashboard, right? You can connect it to your GitHub, but what they do is you are just dropping your relevant files that api.php user controller.php. You click on process and it's going to generate a basic Swagger or definition, right? So if I tell you, right, let's say Himanshu, if I tell you to design a tool like this using Chat GPT, right, write a wrapper on top of GPT somehow and design it, how will you do this, right? We'll do everything eventually. We'll do database design, we'll do the complete HLD stuff, but how will you start with it?
Okay, so first we just have to think about like what we really want to accomplish here. So I guess the first thing should be the query optimization. I mean, like what we will ask the chat GPT to do. I
Okay.
mean, yeah, we just want to write a prompt, right?
Yeah, write a
Uh, and that should give us consistent results. So first we have to,
Right, write a prompt that should give you consistent results, right? And you basically the use case is easy, right? You want to build something that can generate Swagger from code, right? So
yeah.
like you have a TypeScript app, right? In TypeScript, we have something like an index.ts, and then
Hmm.
have some other files, right, present. And then what we want to do is we basically just want to pass those files in the index.ts, the controller. Somewhere down the line, it's a strongly typed language. There will be types somewhere, right? And you use those types, and basically ChatGPT is going to generate. Just ChatGPT is going to do what you manually do as a human being, right?
Yeah.
So
Mm.
your job is to figure out the prompt,
Automate.
right? Yeah. So then the next step is basically you're going to go to Chat GPT and you're going to simulate a conversation between you and
Yeah.
Chat. you will try to see if you can make it, because then once you have done it, then your job is to you take go to the API and do it, right? That's how any Gen AI app will be built, right?
Mm-hmm.
So I already have a chat conversation here, okay? Because
Okay.
I was told to build this, so this is how I did, right? Like, look at this. I have a web application that uses TypeScript plus bun serve.
Mm-hmm.
This is the basic that I've used. Now I'll be passing the index.ts to the endpoint of the app file to you. Now all TypeScript bun serve apps start with an index.ts file or maybe some other file. Again, you iterate on top of it. You see different repos, iterate on top of it. You ask for subsequent file that you will need to get necessary context. Your job is to, and then basically ask for the subsequent. You can find type files. There's some context that I have about TypeScript and bun. I'm passing it here, right? To start with, I'm passing the index.ts file, and after I passed all those files, it generated me a beautiful swagger, right? So it's asking for, so if you see here, right, I have
Mm-hmm.
asked it to send me back a response like this, that okay, I have got this index.ts file, right, and I
Mm-hmm.
need these files back, right? I also need these files because it sees that the index.ts file references this, controller files and all these files, right? Like you have it on top, import star from controller, right?
Yeah,
It's
yeah.
mocking. I'll just mute you, Khushbu. Yeah. So you have this controllers and everything. So it knows, right? You know that
Mm-hmm.
this is where I want to find my controllers, and then it's basically just what you would be doing manually, but ChatGPT is doing it for you, right? It's like a very intelligent intern that have.
Yeah.
So this is how you build this, right? You are done building this. Now you know that this entire context that I have, this is
Mm-hmm.
how I do this. I maintain the context, and I'm going to now the second step. You're actually building this application, right? You're building this Gen AI app. So
So the second step should be like how we want to transfer the files between, like, user will upload it somewhere and how we will just send it to our prompt, like via byte array, or we want to use S3. I mean, things like that we will think of, right? Like
could be. Why
think
would
about files. I mean, like we should think about like how we want to transfer the file to the GPT.
yeah?
Uh,
But
I mean,
you look at GPT, right?
mhm.
Again, S3, good use case you're saying. But why would you say S3?
I mean, that same use case I already like had a discussion recently in my previous organization, so that's why.
Okay,
So
okay,
it was in my mind, so that's why I said it. But we finally used byte array to for that.
okay. Yeah, exactly. So I would say just, just have the text, that cat out the text, right?
Mhm.
And just pass the text to GPT, because at the end, right,
Okay, as a response body.
if you break into the ChatGPT internals, right, and you see that right now, ChatGPT takes in images, right? But what it does with images, it parses those images into byte arrays and stuff like that. So at the end, it's just taking in text, but the
Yeah, yeah.
context window size is increased. Earlier, you could take in a small paragraph as a context, so that's why it couldn't take in images. Now it's taking in images and everything, and it's parsing all of that into text, but the
Mm-hmm.
input is still text. It's still the old chat GPT that taking a paragraph of text. So everything becomes text. So what when you're passing in, why would you passing anything but text, right? Why would you involve S3 and all that? Just pass text, right?
If we want to scale this system, and I mean, if we are having a lot of parallel requests,
Yes.
so in that case, I mean, how we want to handle it?
You are not storing file, right? It's a curl request that you are sending to the from the
Yeah, I mean, server might get overloaded for that. I mean, the memory and all. I
okay.
mean, yeah,
You
that's a different use case, but yeah, we can think of it later.
Yeah, but you scale your servers, right? So you're saying that I'm taking the files, right, and I'm
Yeah,
storing.
it's fine, I guess. I mean, per request, it should not exceed a like it should
Let's
not
let's
exceed.
think of high load. Let's think of that. Like let's think of a billion servers, so like
Mm-hmm.
billion requests, right? Because at the end, the system design purpose is to think in bigger terms,
Yeah.
right?
I one just question in my mind, uh, we are talking about like where this all data is going to be stored, right? Sorry, I joined little late, 5 minutes late. That's why I just want the context.
Exactly. We are talking about where
Okay.
this data is going
Yeah.
to be stored.
Store. Okay.
I mean,
So
how we will just process these files.
Yeah, exactly. So for small systems as well as for large system. So a couple of issues if you are storing this data somewhere other than chat GPT is that a basically the client might not be comfortable with you having their source code on your server, right? With chat GPT you can put out a license that hey, one thing you can do is that you put your GPT key in here, right? And in our application, right? And then we'll put the data in your chat GPT, your company's chat GPT, right? That way, that is an additional thing that you have unlocked. And in terms of company to company, these deals that happen, right? Data privacy is important. So that's an additional thing that you will have unlocked. Again, you can do that with S3, like you put your S3 key, but that's an additional hassle, like why go the
Yeah,
use.
yeah, like we'll have some PII data and all. So not
Yeah.
PII data, but company's data, at least code base.
Yeah. So the thing is that see, you are doing a very
We
simple.
want to like process it in one go. Yeah, that should that makes more sense actually.
Exactly. And see, S3 is for files that are big files, right? You are
Mm-hmm.
putting code here, code. Okay. So code is what? Code is just text, right?
Text should not take that much.
Yeah, it's text. So it's not about even when you think of it, right? It's not KBs also. It's like,
Mhm.
this page of text that it is. How big is it?
Like
So
I
you are
I have had the case with PDFs and all, so that's why I was thinking in that way. But yeah, it's clear
okay.
now. It's
But yeah,
only
think
it
of
should not be that much amount. Yeah, you're right.
exactly. So
Oh, can we, I'm not sure, just guessing it. Can we go for some in-memory database like Redis or something? Because,
definitely, like
huh?
what can be the use case where you want to plug in Redis? Because again, Redis is a costly thing here.
Like for storing the same thing which we are storing in the S3 bucket, like the
What I'm
bytecode.
saying is that in this specific use case, right, where
Huh?
we're getting something, why do you want to store it like that, right? Why do you even want to store it, right?
Oh,
Like
okay, okay.
just think
Huh, huh.
simple. Just think
Got
simple. ChatGPT is
I mean,
already
we can just pass it
it.
from front end to back end,
Mm,
and then back end can
mm,
integrate with GPT, and
yeah,
we can
you're
call
just
directly with that.
Yeah, you're
yeah.
just simply passing that to GPT, right? But
Mm,
if you look at the app that I'm trying to build, there's going to be back and forth between the app and the GPT, right? So I'm
mm.
going to write this down, right? So what I am going to do, my app is going to say that, hey, I this is the index file, right? This is the index file that I'm passing you, right? You tell me what other files you need. Okay. Now GPT tells me, hey, I need these files more, right? And it sends you an array of those files like it just did, right? Then
Mm,
what my app does is, hey, these are the subsequent
you need to upload. Yeah, makes
files,
sense.
right? And I don't send the files back. What I do is I cat all the files, right? And I send a big text of all the files. And what I can do is I can have some custom logic here. Like let's just say, um, in the controller, right? There's a lot of files, there's a lot of functions out there. But what is more relevant to me is the basic controller and the types. Like let's say Chat GPT figures out that the type resides in a type folder or something, and there's a lot of fluff in that folder. There is some big service level function inside that folder. So if
Mm.
I'm passing that to Chat GPT, right, that entire context to Chat GPT, be it I'm passing it as a file, I'm passing it as a text, it's the same thing, because Chat GPT is going to decode it as a text. It's better I decode it as a text and pass that text down to Chat GPT, right? So when I'm doing that, then that's extra tokens that Chat GPT is consuming. My app is bloated. So I can put some custom logic here where I get those files and I myself compress those files in a little way. I eliminate the fluff a little bit because what is relevant is needed. And that could be application specific. And then I just send it to Chat GPT, right? Send it to GPT, right? And then GPT responds that, hey, I need some more files, right? Hey, I need these files more, right? It again responds that it needs a few more files based on the file that you have sent. And then finally, when it's satisfied, when this back and forth is done, right? Then GPT is going to give you back, right? Then GPT is going to give you back, hey, this is the swagger. This is the swagger, right? And it can not just give you the swagger, it can give you the postman collection also, because you have tools that convert postman to swagger, right?
Yeah.
Same thing. You can literally say that. So think of it, right? A better, even better thing, that instead of having to upload this file, what if you do like a package, right? What if you build a package that you just run a command on your device, right? And let's say you have an express app, like all express apps as an index.ts file. So what your package does, it just searches for that index.ts file. It picks up that file, it cats the file, it sends the text to GPT, to your backend server, right? And in your backend server, it sends it to chat GPT to ask for the file. The back and forth happens between the package. So for you, all your effort is you just run that command, you just enter the first file, and and your swagger is generated, and it's your swagger is generated on the device itself. You get two generated, a swagger.json, a YAML file, and a postman.json file, right? That's kind of a use case, right?
Yeah.
Yeah. So if I have to implement it, right, I can think of a very simple implementation, right? You build a front end package. You have a small database, right? Um, what's an implementation you guys have in mind? Like, tell me, is there something?
One thing I can think of is like we need to have a conversation cache, other because there might be multiple requests which will like cost you a lot in GPT
Definitely,
tokens.
definitely. That's the second
Yeah.
level, right?
Yeah.
How we improve on it. So first we have a package, right? And we have a server. We have a server, like basic server, right? And then we're going to improve on it as our application scales, right? As we come across new and new use cases, right? So this package is basically just going to hit the server, right? And what this will store, so if you know how do you send context in chat GPT, right? This is a, where is it at chat context, right? This one. um I just showed you like that back and forth that happens, right? You subsequently keep sending text, and chat GPT maintains that context, right? So do you guys know how that happens when you're using the API? So
No.
okay, so what happens is when you're using the API, you have to send the entire chat in the context as a context. So you have to send the entire thing every time, right? So you have to maintain that chat context on the server, right? So what I can think of in the database, we have something like a conversation history or something like that, right? Conversation history that's maintained, right? And this one will have that context, and it's basically just going to store the chat with the ID of the chat. So let's say I have a repo, right? I have a repo, and in my system, in my server, I'm going to assign that repo an ID, right? I'll write all of this down so it's easier to understand, and then we are going to scale it. So for each repo, I have a repo ID in the system, right? And let's just say that once I start this conversation, I can have a conversation ID, right? So this is a back and forth conversation that I'm just starting with ChatGPT. Like my package is going to do an init. So it's looking for a swagger.yaml and a postman.json file, right? So I start this conversation, and then what happens is this hits ChatGPT, right? GPT. So this server hits chat gpt, it gets back the response, it stores the conversation in the conversation history with the timestamp. The timestamp is the easiest way to see what is the flow of the conversation. Anytime you do a select star, it comes as the timestamp. Then every time I hit it, I get the conversation history, and I um get it back, and I just basically simple way to build this system, right? I get back the conversation and I send it back to the package, right? And then finally when it's done, I am just basically my package hits this server and it gets it hits chat gpt, it gets back the YAML, it sends back the YAML, and this conversation history, we can save it or delete it. That's up to us, right? How do we now you guys tell me, how do we like optimize this, like if there's a large amount of network call, what all can we add to it? Firstly, is this clear, or is there any doubt in what we have discussed till now?
I think it's clear for now.
Okay, that's great. That's great.
Yeah,
So
that's great.
some use cases, one or two use cases where we can optimize this, or we can discuss other Gen AI apps also.
One thing I wanted to ask is, suppose we keep the conversation history. So in
Okay.
that case, what will be your key? Like we will keep the key as the prompt. I'm
Yeah.
assuming that.
The key is the conversation ID.
Okay.
Yeah. So with the
No,
conversation ID, yeah.
one optimization I could think of is,
Okay.
like, suppose there are two prompts. They
Okay.
both ask the same thing, but only the language is different.
Okay, two prompts, they ask the same thing, only the language. Yeah, definitely.
Uh,
If
yeah, so
if
that,
the user is hitting it multiple times, right, but it's the same, so you need some kind of caching layer in between,
yeah,
right?
that's what I was
But-
saying.
Yeah, exactly. But whenever you're doing this kind of Gen AI, everything, whenever you come across a use case and you optimize it with the GPT calls also, right? So let's think of it, right? My index.ts file is exactly the same, right? But my controller files and stuff are different, right? So even if the user, yeah, okay. So my index.ts file is the same. My controller files and subsequent files are different, right? So what happens here is, if you think of it, right, so I have my index file, but I am already doing a back and forth with chat gpt, so I cannot save on the calls, right? Because some change might have been done in the controller files or in any files, let's say 3 4 layers deep, right?
Yeah,
But I'm so the back and forth will anyways happen even if I hit it. So how do we save that? How do we save that? So we save that, and something I'm thinking of is, what do we do is that the first time this hits GPT, right, for a package, we generate a kind of JSON. We generate a kind of JSON which tells that the first time this conversation is done, right, we got back the files. We generate a JSON that will be like, let's just say something like this. Okay, files to look, and it has the array of files. Very simple. Next time you hit next time you hit with it, right, it's not going to do a back and forth with chat gpt, it's just going to cat these files, right? It's going to take all the text, it's going to put all the text in a long file, and it's just going to send it to chat gpt, right? Just one call for the first time when you're in it, and then maybe when you want to do a hard refresh, right, then you can have an additional command in your package for a hard refresh, and that will recreate this file, that will again repeat that process. That makes it very simple, right?
yeah. That makes sense.
So this,
One
yeah.
one thing I can think of more is, like,
Okay.
we can create some kind of embedding of the conversation. Like this kind of problem I faced recently in my job.
Okay.
So what we did was, we saved the prompt as the key.
Okay.
So suppose what I do is, for each prompt I create a, suppose, LLM embedding with some fine tuning, right?
Okay.
And
Yeah.
and what we do is, next time we get a prompt,
Okay.
we run a similarity algorithm. That fine tuning gives us a number. So it has some embedding. So what we do is, we try to find the closest number, like some kind of vector DB.
I get your point, but the thing is, where you're going is in the vector DB embedding direction, right? So when we use that, it's like other devs in the system also have to learn. So these are when we are doing like chat GPT wrappers, right? We keep it simple because what is the purpose is this like some hot thing that we are just going to push it out in 2 weeks, right? So the purpose here is also to understand a wrapper on top of chat GPT and not some, embeddings, vector databases, all that stuff. So that's for, more complicated use cases when you are building some, not more complicated, but I can think of it like the cost is not going to be that much. We are not going to make that many calls, right? And if the cost is much, we can also bill the developer, right? That is like when you
Yeah,
really reduce your costs because chat GPT is much more expensive than embeddings and stuff. I know other people did not understand this part much, but that's okay. But again, this is kind of how you build a basic Gen AI app, right? You start with the GPT use case, and then you start building around packages and stuff, and then you optimize on that, right? Um, I want to do just one more, right? And then we'll do this one system design of Tinder, right? But was this good? Like, did you guys understand everything, right? Like, if your company comes to you and tells you that, this is a Gen AI app. I don't know, use the term Gen AI, but this is a chat GPT wrapper we want to build. You guys would be able to, somehow think of something, right?
Yeah.
Yeah, definitely. I mean, everyone else is very silent, but I guess everyone understood. Anyways, so then we move ahead, right? Let's say something like, how about our meeting summarizer, right? Let's say like you have a meeting that happens, right? Like there's a tool, right? Let's say we have interviews that are happening. So after the end of interview, I want to build an app, right? Build something that that basically summarizes interviews and sends feedback, right, to candidate that hey, this is what you did right, this is what you did wrong. And let's say it also sends a feedback back to, again, this is a very simple thing, should be done in like 5-10 minutes, we'll keep for this. So you have an interview that happened, right? And when that interview got over, let's say that analyzes the interview and just tells that okay, this candidate said wrong to this answer this many times, maybe gives out a percentage or something. And it also tells that to the recruiter that this should be passed or not, or what decision to take. So it sends a feedback down to both ends, right? uh how would you build something like this?
similar kind of structure. Like we grab the conversation audio
Okay.
and using some like this part, I'm not sure, but we convert it into text and send it to this LLM.
Exactly. So you already have tools that convert. So whenever you have a meeting, right? Like here also this meeting is being recorded. There's a video file and an audio file that's being generated. So the audio file is low in size. GPT has processed to parse this audio files as well, right? But again, you have audio file parsing tools, right? These are like exist since 2011, right? So basically you parse that audio file and you generate a text, right? A text transcript of, this is the interviewer. And then what you can add a little bit is you can separate the text based on pitch, right? So like the interviewer goes like this, the candidate goes like this, right? They have different pitches. So you take those pitch and then you separate them, you form two conversation threads, right? That this conversation happened. And then again, this is something that I'm thinking, ad hoc. It's not like I have planned this, I have read some books or something like that. I'm just thinking this is how you separate them, right? So I want you guys to also be able to think like this, right? Right now, this thing that I thought that, this is how you separate the context between those two people, right? And then you basically generate a whole transcript of the conversation, that candidate interview, like that. And then you just send it to GPT and GPT does the magic, right? So simple question, we did that, right?
I mean, I guess the modern tools like Zoom already have this feature of like voice recognition and all.
Yeah, voice recognition and all. But again, just my thought that how voice recognition could work under the
Yeah,
hood,
yeah, I got it, got it. I
right?
guess like this will only work for question answer based interviews, right? I mean, if
Okay.
interviewer is asking something and candidate is giving some answer, but not with some DSA or design interviews.
Definitely. For let's just say DSA or design interviews, we can extend this tool, right? So the
Yeah.
interview happens in a environment that is let's just say lead code or something like that, where
Mhm.
that candidate, whatever he's writing, like his writing, typing speed, everything is checked, right? That you kind of take snapshots at a given point of time, like let's say every 5 seconds you take a snapshot of what the state is, and you see that what is the speed at which the candidate is solving the problem, where is he stumbling or what is happening. You can also understand if the candidate has cheated, right? Like if there's a, again thinking ad hoc, right? There is a you're taking 5 minute snapshot. If the candidate is not able to do like machine coding interviews, right? How
Mhm.
machine coding interviews happen is it's a 1 hour interview, and what happens is you are just left alone, right? The interviewer drops off the call. You can literally just put the question on chat GPT on a parallel, if you have a parallel device, and just copy paste that answer, right? So the machine can find out those patterns, right? Because it's taking snapshots at given points of time, and it can analyze those patterns and see that if you cheated or not, right? If you're writing very fast, right? Or it can also track your face, right? If you're moving this side, that side, if you're switching off the screen and all that,
Mhm.
and it can analyze, it can just see that. You can put a code in chat GPT and see that how accurate that is. So that is a way you would do that, right?
We can assess like code quality and other factors
Definitely
also.
code quality, other factors, which design patterns it's using,
Mhm.
right? And all that could be.
One, one, one complexity I can think of here is like it is not very well in other languages as well. Like in every model mostly understands English very well, but
Okay.
yeah, suppose there is some language which not many people understand. So this will kind of create a complexity for them.
People talk in English during interviews, right?
Yeah.
Yeah,
I was
like
thinking like one
for some
use case
countries
for
like
that.
Japan or like
Yeah.
Yeah,
Russia.
you can have interviews like that, but in general, also even in Japan, people just so when you build this kind of tool, like an interview tool, right? You
Yeah,
sell it
you are expected.
client to client. You don't go and just roll it on the internet that hey, who wants to buy, just buy it. You go and pitch out to client to client. So it's more like you get a market who's speaking English that's good enough. So that's how you start thinking, and then there are always tools that build on vernacular languages, right? But you're building GPT wrappers. Your job is to just get something done in 2 weeks and make some money off of it, right? So
Correct.
that's the thing, right? And now we just did this because I wanted you guys to understand how these tools are being built, right? And there is not good resources available on the internet. um like there is none, I think. No resource available on how we build this GPT wrappers, right? But it's pretty simple if you think of it, right? Like you just build a wrapper, you understand the use case, you just pass it to GPT. Like every company is doing something on top of this. They're integrating their existing systems. But okay, let's do the main problem today, right? System design of Tinder, right? So we're gonna do the functional requirements first, right? Basic let's not do functional, non-functional like that, right? But what are the basic requirements of, like, how many of you use Tinder? Have used Tinder ever? Or some dating app or something like that? Why so much silent?
Yeah, I mean like
Okay.
basic requirement should be like first
Yeah.
thing is uh should be, I mean, how should we start it? The swipe function or the
Yeah. Like
matching
swipe and then matching.
match and then like super like these are I guess.
Yeah, like super like. Okay. I can think of it. And then I can think of other features like chat, right? Chat is
Yeah,
a
that is really important.
But again, when you look at Tinder chat, it's not like WhatsApp chat, right? You don't need it to be a very advanced kind of chat, right?
Yeah.
You don't need web sockets and stuff there. You can just have, long polling and stuff there. Because if you see Tinder's chat, right, it's not that advanced. Um, Again, swipes matching, like filtering,
Mhm.
search. Is that a feature? Because let's just say that you put your filters, your preferences, right, and you're able to search for
Yeah,
someone.
like based on distance or age or these kind of
Exactly.
filters are there.
Exactly. You do these filters and you search. But if you look at Tinder, right, in general, it's basically like a hyper local kind of app, right? Just like Uber. So it's
Mhm.
not like Hotstar or something, right, where there is content that's globally available and you're consuming all of it, right? Tinder is more like when you think of Tinder, right? Think of it if there was an app that is specifically built for your city, right? A Tinder Bangalore or something like that, or Tinder Kolkata or something like that. It's still cool with you, right? What difference would it make, right? Because at the end, you're more like looking within a region only, right?
But they do have a feature of like global search or something.
Definitely, you have a feature of global search, but the point is that, see,
Most of the people are searching for people
yeah,
nearby
yeah. There's
to date.
something like heavy load, right? And there's something like low load, right? When there is like very few people searching for a certain feature, then
Mhm.
the existence of the feature can be very easy. That feature can break and no one will care. And you don't have to brainstorm a lot into that feature. Like what if a
Like
million
a side feature or something.
yeah, like if a million people today turn on global search in Tinder, Tinder will probably crash, right? Because they have
Yeah,
not
exactly.
thought like that. They have thought it in a hyper local way, just like Uber has thought it, right? So now we are going to go a bit into design, and as we design, we iterate together and we find out things, right? I think the others are like really silent today. I don't know why, but like we first have the phone, right? The device, right? This is the device from which the user is like opening up Tinder, right? And what's the first thing that you guys can think of when a user opens up Tinder for the first time?
So they have to create an account.
Exactly, they have to create an account, and I think we already discussed this. You were not in previous lectures, but
Oh,
so the
oh,
service,
okay.
right? You have this server. Okay, sorry, server. So we have a user service, right? We are breaking it down into microservices, and then we'll decide on things like Kafka ingestion and all that stuff.
Okay. Yeah.
Because I think when you break it down into microservices, it's easier to understand. Then and we also did like 8, 9, I think over 10 system design lectures happened, and some services keep coming in common, so you can understand how that architecture works, right? So first, let's break down into microservices. When a user on Tinder comes in, first he creates an account and then he uses the user service, right? What are the other components that you can think of is let's just say chat service I can think of. So I'm going to put it a little far because I'm not going to use it immediately, right?
Mm.
Then I can think of once he has created an account, right? Um, User service maintains his profile as well, right?
All the
Uh,
data.
yeah, I can think of a service known as a discovery service, right? What this discovery service might do is that, let's say, I'm a user, right? My profile is out there, everyone else's profile is out there, so I have these user profiles, right? And which users are near, like which users, right? In a circle, so it's going to find those users out. So what I can think of in terms of a database structure, right, how this discovery service can work is, let's just say, what if we have a JSON like this? ID is the user ID, right?
Mm.
The user ID. And then what I can think of is, um, coordinates, right?
Um,
Let's say, what do we have? We have a x coordinate and a y coordinate, right? Which is basically, what are those things called in the
Longitude, latitude.
longitude, latitude, right? So we have a longitude and we have a latitude, right? So we have a longitude and a latitude, right, for each user, and this is something that we did as part of the Uber system design. So common things, right? Like if you did that, you understand this, why I came up with this so easily, right? But
For the distance, right?
what?
Like for the distance, like the nearby people and all.
Right, yeah. So whenever if you see like all the system design, right, there's always something that is common between 1 and 2, 2 and 3, right? So the more system design videos you do, the more if something unknown is thrown at you, right, system design or notification service or something like that, you would be able to take those Lego blocks that you have learned and then just put them in, and you have beautiful system design, right? There's not a lot of things in system design like queues, Kafka, SQS and all that, and then you have databases and then services and stuff. So there's not a lot, but again, when I talk about discovery service, right, what all does it have? It has the user ID, it has the user location in terms of latitude and longitude, and it has what else can it have? It has the user preferences, right?
Mhm.
User preferences is not a like it could be a JSON of all the user preferences, right? You can do that. And then what else can I think of? I can think of um user preferences only, right? This much I can think of, right? What is the other thing that can happen on Tinder is that let's just say there is a user, right? And that user is popular, right? That user is popular, like that Tinder shows that user to 10 people, and those 10 people right swipe on it. So this is a hot user, right? Like there could be hot and cold users, right? So that hot user is now going to be shown to the next 100 people that come on Tinder, and they are going to swipe right on it, right? It's just how something like LinkedIn would work, right? There's a post and you go and see that post, and LinkedIn shows that post to 10 people, and 10 people like it. 10 out of 5 out of 10 people like it, so that's a very powerful post. So LinkedIn will show it to the next 1,000 people, right? So just like that, Tinder would also want to do that, right? So what I can think of is a score, right?
Score or priority, I mean, yeah.
Score depends on a lot of factors. If someone is absent from Tinder for 6 months, his score can go down, right?
Mm-hmm.
So score is dependent on a lot of factors. Score can also be dependent on that, so the discovery service can backfeed into itself, right? And it can increment the score, right? And this is again a little tricky, which we need to brainstorm it together. So we have this discovery service, and let's just say ID, user ID, latitude, longitude, user preferences, and score. And we have multiple users. So now a user is coming to this platform, right? What is the way that he will search? Okay, let's think of it, right? First, what it's going to do is it's going to run a simple math or something like that let's just say my current user's latitude is X and his longitude is Y, right? So what Tinder can do is do from X plus 3 to Y plus 3. Makes a grid, right? He's here. So this square, it makes a square. Now, what I can do is I'm going to go to discovery service, and from X plus not 3, let's make it 2. 3 will be very big, right? So mm, X minus 2, and there are indexes on it. There are indexes on it, right? I'm thinking this ad hoc, right? I want you guys to think this ad hoc also. So from X minus 2 to Y minus 2, if I have an index on longitude and if I have an index on latitude, right, I can find out all the users that are in X minus 2, right? And then I can do another select. So select star from users where longitude equals to X minus 2, latitude equals to Y minus 2. And then I just do two for loops on it, right? And I find out all the users that are within that latitude and longitude, and ON call, right? A very fast call on the DB. right? And again, when I talk about Tinder, like the way that you assume Tinder shards its DV is obviously going to be by the location, right? It's going to shard by location only. So one more optimized way of searching is that you can when the user is in that location, right, he can just go and search in his shard only, right? Like his search is going to hit his shard, and then that's going to just hit the discovery service, and then it's going to run its algorithms, right? That what are the users that's more suited for this person, right? But let's think beyond, right? This is a person that has certain preferences. You want users who match those preferences. So based on that, I think it can give them a score, right? So what I think of is that if a user is there, right, and within his geolocation, how many more users would be there? There would be 500 users at max, right? I'm not thinking about global search, right? We do
Yeah.
local search, right? So within my city, there will be 500 users that match your basic criteria. Just you took a filter by age, lower
Mm-hmm.
sets. Because there are some hard filters you will set, right? You set a filter by age, you set a filter by um other some hard filters will put your pool will be less. Now there's machine learning algorithms you can run that, and based on that you can sort those 500 users at any given point of time, right? So for a user, there's going to be like score, right? And you want to cache these results because like A to B, like this is a user, right? What is the score? And then you are going to filter out like that. So like I'm just thinking out loud, but what we can do is for each pair of users, right, within a radius, what we can do is we can figure out a compatibility score. Does that make sense?
Yeah, using ML.
Yeah, using ML, we figure out a compatibility score. And I can
Based
think
on
of
this.
that there will be just a microservice just dedicated to this, right? Where there will be MLs running and there's a database which is just for the compatibility score.
Mhm.
ID1, ID2 compatibility score, like that, right? We figure out a compatibility score and we cache that compatibility score. So it's super fast. Whenever you want users, you take out 500 users, you check their compatibility score and you just sort them. I'm not thinking of global search in any way. We don't have to actually think of that because it's a feature very few people uses, right? Um, then we have likes, right? Likes, super likes, and stuff like that. But that logic is, I think, easier. Like one more service I can think of is a notification service, right?
Yeah.
It's a must have for like any service, right? So whenever you super like someone, it's going to go
Pop
down
up notification.
notification like that, right? So one way, how do you maintain this like super likes and things like what do I say, things like if I liked someone, I want that person to show up at the top, right? If as compared to the other people who haven't liked, I want that to be the second person to show up, right? So what I can do is I have that service, right? I already said I have the service that maintains the, let's name it let's name it let's name it the compatibility service. Compatibility service, right? Now this service is going to maintain a compatibility score between these two users, right? Now what if I have an option to modify the results, right? I have an option to modify the results. What happens is again, you can think of the table structure. We'll do that in a while, right? If I like a person, that compatibility score will shoot up, right?
Mhm.
Like add 500 to the compatibility score if I like that person, right? So the compatibility shot up. And now but if I like that person and I and the second person unlikes that, then their compatibility becomes zero, right? Because it's she has already disliked. But you will see one thing on Tinder, if you keep liking, right? If you keep liking a person, sorry, if you keep right swiping, and you end all right swipes, right, then it will again show you those people that you left swiped on, because the compatibility score becomes 0, but it's still there, right? And it might be improved in later, so each like and super likes comes with a TTL, right? Why is everyone so silent today?
I mean,
Yeah.
what is ETL?
Yeah, I've got it. I'm telling.
Okay. Okay. Shreyam, are you there? Dash, Abhijit, Digvijay. Okay. Everyone's very silent. I don't know. Like, but yeah, still, like, there's this compatibility score, right? And then that, so this likes and super likes will come with a TTL, right? So you can basically, user one, like, let's think of building this out, right? What could this be, right? And there will be indexes on both, I think, right? So ID user one, right? ID one, ID two, right? ID two, right? And then you have a compatibility score, right? And then you have a compatibility score which keeps getting updated, right? So like could be like let's just say if user one likes user two, right? What we can do is like uh you know and then we add this like, right? We add the timestamp of the like, right? And again, I'm just thinking ad hoc, the real thing could be something else, and unlike or something like that, if one user has disliked the other user, right? So each one of this comes with a TTL, and that's why I'm keeping the timestamp. So the compatibility score will vary if the TTL changes. If the TTL expires, then the compatibility score will again be, it will cancel out, and it will increase or decrease depending on, what happens to the likes, right? So that takes care of the likes and the super likes. Filtering search.
I was just asking one thing. I mean, do likes and super likes actually like work like that, or they have a different mechanism? Because I think like they are only there to show that you are interested in the other person.
Yeah, so but if you do a deep dive, right? I've spent, like, don't ask me how I have this knowledge, but if
Yeah, I don't have any deep knowledge on this. That's why I asked.
like that's why I'm saying don't ask me how I have this knowledge, right? But if someone likes you, that becomes the second post, right? Like
Okay.
if you've seen that, like Tinder does not put it on the first because they want you to buy the premium, right? But it becomes a second post, and it shows on your middle star that, someone's interested in you. So there's some algos that they run behind the, it's not just, you like someone and that person shows up at the first. So
Mhm.
they use those, and if you have a lot of people who are liking you, then they will have to, filter out. So that's why that compatibility score makes everything easy, right? For a like, you assign a very high score, and that
Mhm.
just add that score. So if you have 50 people liking you, right? So your default sorting order is still maintained but those entries are pushed up in the front, in the second
Uh,
front.
like
So
for other users.
yeah. So I'm also building, like, think of it. I'm not just showing a like super like mechanism. I'm basically building the whole algorithm for matching, right?
Mhm.
Right. We are finding
This
compatibility.
compatibility score will like increase for all the users, or like for a pair only?
No, for a pair, like if A liked B,
A likes B, then their compatibility score.
yeah, that's what the compatibility service is storing, right? For a small
Mhm.
region, right? So Tinder can run advanced machine learning algorithms for this small region. It can have those costs because, let's just say, so there are these cohorts of users that are being built, right? There are these
Mhm.
cohorts of users that Tinder is building, small cohorts, right? Tinder Bangalore cohort, right? Within which you have 1,000 users, and it's going to run a machine learning algorithm within those 1,000 users, and it will be generating those pairs of users, right? And then for each pair, it's just generating a compatibility score once, and it's caching it in its system forever, right? So you
Yeah.
don't need to generate it ad hoc. So it's just once per user, right? So each new user joined, it just generates that once. Again, there's it can do more simpler, it can have some level of simpler filtering, and then more complicated, machine learning filtering, right? Like age and all that simple filtering, right? So notification service is there, like super likes is there. So then when you're matched, you have this chat service where you can, chat with the person you have matched with, right? So how would chat work, right? The thing is that I don't think Tinder uses something like web sockets and all. The chat in Tinder is pretty simple, so I think it's more like long polling, right? When you open the app, it just polls the server and it sees that, hey, there are these chats that have come, so you push it. Because Tinder almost never sends a notification from the server to the client. Like if you have someone that has chatted you something, it won't usually come in, right? It might come in as a push notification, right? Which is a different mechanism as compared to what WhatsApp will use, right? It uses WebSockets. But Tinder chat is simple. You can say that it uses WebSockets. That's totally fine, right? Because the actual implementation might differ. But and then filtering search is also very simple, right? So that's
I
kind
mean, chat is not a main feature, I guess, like matching and
that
all.
is the main feature. That's why they haven't thought that much,
Mhm.
right? Into
Exactly.
yeah. Then you
Most
have
people just chat on Tinder for like first few seconds and then they will just move out.
yeah.
They're interested. I mean,
Yeah.
just
Okay. Yeah. You can say that. Then we have filtering search on it. So filter is also easier because once you generate a compatibility score, filtering is also easier if you want to, filter is more like hard filters, right? So you can directly take it from like the compatibility service itself, that these are users that I don't want in my search results, right?
yeah, it's like if filter to the list.
Yeah, just a filter to the list. So Tinder does not show you a lot of options anyway. So it's not like you're dealing with a lot of traffic, right? Databases. So everything in the Tinder architecture is sharded, you can think of. It's not like, one application is dealing with too much traffic. Um, from the database to the server, everything is very locally sharded in Tinder, right? But then again, so yeah, that is my proposal of system design of Tinder, right? What changes would you suggest, or what questions do you guys have?
I guess locally sharding makes sense in case of Tinder because it's applicable to local profiles only.
Definitely. Yeah, so like what questions would you guys have from this? Anything, like any improvements or anything you guys would, any questions you guys would have? Nothing? Am I sure?
No, I guess
Okay.
it's pretty clear for now. Yeah.
Yeah, it's pretty clear, I think. So if this comes in an interview and you say this, you should be able to like make it through, like it should be okay. Someone chatted something. No, nothing. Okay. But yeah, so I think that's it for today's lecture. Like we did 1 hour, right? So one thing I wanted to say is that we are eventually so we are doing low level design along with it, right? So some of you guys who have joined who are new, what I want to do is just do the day one exercise, right? This one, right?
Okay.
Put it there. And we will start with this LLD, like creational patterns, and then all the design patterns. But we're doing it like alternatively. So next lecture will probably be about the 5 creational patterns, right? So it's going to be LLD, and then we'll like into an HLD, right?
So
So
for LID, like what language you are using?
we are using TypeScript right now. So
Okay.
but you can write in your language, right?
Okay, that's fine, right? I will
Yeah,
write it.
so some people have written, I think, in but so I saw that a lot of people did not do this. Like, so we will do this in the class itself. Everyone will hands-on do this in the class itself, right? That's something I'll try to change, right? So everyone submits a PR, and that way, because LLT is about practice, it's not about, um,
Yeah.
it's more just, practice, like not like DSA that, something hard comes. It's just easy. You need to be confident and just, because a lot of people us don't have that practice, so that's creates the issue, right? But I think that's
We
good for
like
today's session.
raised a PR, so it
Yeah.
too much.